We may be able to break free from the rare earth shackles of our dependence on China. This time it will be an article about Sansonen, who is just 17 years old and working on a new motor. Let's start with the article. Sansonen learned several years ago about rare earth-dependent motors as a problem for electric vehicles. From there, he became interested in improving the performance of rare earth-free, synchronous reluctance motors. Over the course of a year, he created a prototype that produced more torque. The prototype is made from 3D printed plastic, a steel rotor, and copper wire. It won the top prize at the International Science and Engineering Fair. The key to Mr. Sansonen's invention is this part of the description. Instead of using air gaps, Sansonen thought he could incorporate another magnetic field into a motor. This would increase the saliency ratio and, in turn, produce more torque. His design has other components, but he can't disclose any more details because he hopes to patent the technology in the future. To be honest, this is not very clear, is it? It says that the details are secret because of the patent involved. Also, the result seems to be a 39% increase in torque. And well, that's all I have to say. It's just great, isn't it? So I did some research on motors, so let's look at a few more together. In the old days, brush motors were used in many industrial products, and then brushless motors came out. Brush motors were used by people who were doing Tamiya Mini 4WD. I was familiar with them because I used hyperdash motors. Brush motors have magnets on the outside and coils on the inside. The brushes are what switch the current in the coil. Toshiba's YouTube was easy to understand, so I'll put the link in the description section. If you have a motor in your hands, do you remember screws sticking to the sides of the motor? Then came brushless motors. In brushless, the coil is on the outside and the magnet moves to the center. Again, Toshiba's YouTube is easy to understand and the link is in the description section. If you understand brush motors and then look at the explanation of brushless motors, you will probably think, well, that's a change of mind. Now, here is the explanation of synchronous reluctance motors. Reluctance motors look similar to brushless motors, but their greatest feature is that they do not use magnets. Instead of using a magnet, which is a rare earth, iron is used for the rotor. The reason why iron is used to rotate is very easy to understand on the LESICS YouTube. It is much easier to understand than if I explain it in words, because you can see it visually. If you watch the video, you will think that iron has this feature. So, if you understand the video, you can see a little bit of what Mr. Sansonen was trying to do. It's roughly around 11 minutes into the video, and I will compare this explanation with the written article. I will use another Toshiba's diagram, as it is easier to understand. The article said that instead of an air gap, a different magnetic field was incorporated into the motor. So I would expect that the flux barrier in the diagram is a different shape and a different coil arrangement. I think this is a different idea of placement than the conventional theory of reluctance motors. By the way, as for the use of reluctance motors, Tesla has announced that it has been using them since the Model 3. In Japan, Wikipedia states that Mitsubishi Electric Corporation is also developing such a motor. On November 26, 2020, Mitsubishi Electric Corporation announced the development of the world's first synchronous reluctance motor for rolling stock in its control technology. The motor has a rated output of 200 kilowatts class and a maximum output of 450 kilowatts class, and is said to reduce losses by 50% compared to existing induction motors. The motor will be installed in Tokyo Metro railcars and its performance will be evaluated in actual railcars through nighttime running tests starting in March 2021, and a total of 12 nighttime tests were conducted from March 24, 2021 to April 14, 2021, confirming that it can be used in actual railcars, Tokyo Metro announced. Thus, this motor is an area of active research and development. If Mr. Sansonen's idea can increase torque as the result, the applications of its use will increase considerably. It would be difficult to explain the difference between torque and power, so I won't go into it here, but torque allows heavier objects to be moved more forcefully. It is not an accurate expression, but simply put, it can be said that even motors that do not use rare earths will be able to produce high power. It is amazing that he is able to think for himself and incorporate new ideas at the age of 17 in the midst of these intense technological innovations. Summary. Motors have been dependent on rare earths, but recent developments have made them less susceptible to the effects of rare earths. Even if it is the same reluctance motor, there is a possibility to improve its performance by new ideas. When we look at the mechanism of the key points of this invention, we can predict that it is a change of conception. In other words, it may be possible to commercialize the product without changing the raw materials or the manufacturing process drastically. This channel will quickly bring you interesting tech news. If you're interested in watching again, please subscribe to the channel and wait for the next video. Thank you very much.